Hello, Anthony Carruthers, Better Lesson Master Teacher Project. And in this video, I'm going to be showing the demonstration that I do for students to show why the golden rectangle construction works. Okay, so while this is a demonstration, I do like to involve students in the demonstration and make sure that they're actively participating and thinking as the demonstration is going on. So basically, the goal is to show that this construction actually leads to a golden rectangle. So in the first place, we should kind of see, and I will point out to students, that E is the midpoint of segment BC, and that ABCD is a square. So we're going to actually label the sides of the square 2x, and we've used this technique over the course of the year in different contexts, basically to prevent us from having to deal with fractions. As we can see, that side of the square was cut in half, so that would make this x and x. All right, if that's x and x, that means that segment AB is also 2x right there. Okay, we know this is a right angle because it's a square. And these are all things I'd be kind of pausing to discuss with students and making sure they understand why. Okay, by Pythagorean theorem, I'll save the work here, but I would actually show it to students. But by Pythagorean theorem, we would get that the length of this hypotenuse, segment AE, is x square root of 5. Okay, so we'd also just kind of want to reiterate what the goal state is. Okay, the goal state is to know what length divided by width is, and in our context right here with the big rectangle, the length over the width would be basically segment FC over segment DC. All right, so that's what we're working towards, and we already know that segment DC has been denoted 2x, so that'll be 2x. So the real question is, how do we figure out what FC is in terms of x? All right, so we'll start doing that. So right now, what's keeping me from knowing FC, and this is something I would ask the students, like, what additional information do we need to know in order to know FC? Well, we basically need to know the measure of segment FB. So if we knew that, then we'd know the length of segment FC. So let's see if we can work our way around to that. What I do know is that an arc has been traced that has radius AE and center E. So for that reason, I know that FE is the same as AE, because all radii of a circle are congruent. And we already know that AE is equal to x radical 5. All right, so basically now we know that FE equals x radical 5. And if that's the case, that FE is x radical 5, then that would make, here on the diagram, x radical 5. And so then I might ask again, to students, now do we have enough information to say what the length of segment FC is in terms of x? Okay, so at this point we should see that basically FC by segment addition postulate is just EC plus EF. Okay, and we know that EC is just x, and we just figured out that EF is x radical 5. So that would equal, x plus x radical 5. All right. So in that way, now I know this ratio, which I had started here, is going to be x plus x radical 5 all over 2x. Okay, and then that, of course, simplifies to 1 plus radical 5 over 2, which is the golden ratio. So that's the demonstration for students. They would also need to show that rectangle GABF is also a golden rectangle. And that's something I would leave to them to see if they've basically understood, what I've demonstrated here. But it has a subtle twist on it that makes sure that students are able to do their own independent thinking. So Anthony Carruthers, Better Lesson Master Teacher Project, and this is how I prove that the golden rectangle construction works.